Hey guys, welcome back to another YouTube video. Right? Welcome back to All About Mathematics. And the topic that we will be looking at tonight is factorization. Please remember to like, share, and subscribe, and to turn on that post notification bell. Please share to your friends and family so they can get the help that they need. Now, today we will be looking at factorization. And when we talk about factorization, what first comes to our mind, right? Now we talk about factorization, we think of factor because factorization derives from the word factor. Now, we would have known from high school or from primary school that a factor is a number that can go into another number without leaving any remainder, right? So, for example, we have 4. Factors of 4 would be 1, 2, and 4 because they can go into 4 without leaving any remainder, right? Now, in terms of factorizing is basically you expressing a number or an expression as a product of factors. So instead of writing down that number or that expression, you would basically write it in a form which is represented by its factors or which is expressed in terms of its factors. So for example, where we have 10, right? We can write 10 in terms of its factors as 5 times 2, right? So factoring is to write an expression as a product of its factors. For example, we can write 10 as 5 times 2, where 5 and 2 are called factors of 10. Please pay attention to the brackets. Brackets mean multiplication. So whenever you see a bracket, for example, you would see 5 with a bracket and probably numbers are letters inside the bracket. The 5 is actually multiplying what is in the bracket, and that is the distributive law or distributive property, right? But we're not on that. So there are different methods that we can oftentimes use to factorize. We factorize by using difference of two squares, highest common factor, perfect square, by grouping, and you also using the AC method. But we're not going to go through all the methods today. We're going to just look at using the highest common factor. Another day we can look on the others. And I'll also post videos containing how to solve difference of two squares and AC method and all of those stuff. Now, here on the screen you can see an example, right, of an expression. There are some important properties that we need to identify when solving, or not solving, when factorizing expressions. So we have the terms, we have the variables, and we have the coefficients. The coefficient is a number that multiplies the variable, right? And the variable is the letter, right? That is multiplied um, by the coefficient. And we have constants, which is a number that does not have any variable, and we have term, which consists of coefficient and variable. So here we have three terms, right, which we have 3x plus 21y minus 6x. Based on our prior knowledge of algebra, we would have known that we can only add or subtract algebraic terms only when they have like terms. But in the event where there are no like terms present, then we can't add or subtract them. But if we multiplication, if it's a case where we are multiplying them, then we can go ahead and multiply um, unlike and like terms. Now, in this expression, we can identify that there are actually some like terms present, right? We have 3x and we have negative 6x. And they are like terms because x is common to both, right? So when we have like terms, what we normally do to make things more easier, we normally group our like terms. So I'm going to go ahead and group my like term. So 3x. Please pay attention to the sign when grouping. The sign that is present in front of the in front of the term, please maintain that sign, right? Or bring that sign when you're grouping. So I'm going to have 3x minus 6x minus 21y, right? And now we can go ahead and we can solve and then factorize. So 3x minus 6x is actually negative 3x, right? Because it's like you owe in 6 and you have 3 to pay. And then we still have our, no, sorry, I'm so sorry about, this should be positive. So it should be positive 21y, right? Maintain the signs, very important. So negative 3x plus 21y. And then we can go ahead and factorize. So we're going to factorize using the highest common factor that can go into the expression, right? The highest common factor of negative 3 and 21 is actually negative 3, right? Because negative 3 into negative 3x is going to leave us with x. And then negative 3 into 21 is going to give us negative 7y. So negative 3 into negative 3x is going to leave us with x, and negative into negative 3 into positive 21y is going to give us negative 7, because negative divided by a negative gives positive, and then negative divided by a positive, or positive divided by a negative, gives negative. So this is our answer. Negative 3, open bracket, x minus 7y, close bracket, right? And this is our final answer in terms of factorizing. Moving on to the next question. In the event where we have 5x plus 30xv, right, we identify that x is common to both the terms, but it's just that 30xv is actually different from 5x, right? But we can identify that x is common to both terms, right? And also 5 can go into 5 as well as 5 can go into 30. So our highest common factor right here that we can use to factorize this expression is 5x, because x is common to both. So 5x, so 5x into 5x goes 1 times, right? Plus 5x into 30x goes 6v, because x is 5x into 30x is, the x are going to cancel each other, and it's just, I'm going to just left with 5 into 30v, which is 6v. Right? And if we go ahead and factor it out, we should be able to get the same answer. Right? Because 5x times 1 is going to give us 5x, and 5x times 6v is going to give us 30xv. So this is our final answer. Moving on to this question, 15xy minus 10xy is just the same principle you're applying. Identify the highest common factor of 15xy and 10xy. We realize that they both have the same variables. They both have x and y as their variables, right? So this, we can just go ahead and just subtract them, which 15xy minus 10xy is going to give us 5xy Because 5 minus 10 is 5. 15, sorry, minus 10 is 5. Leave 5. So I'm left with 5. But can we factorize this? You can just leave this as your final answer. But for you to develop the concept, you should be able to identify whether you can factorize the expression or not. Well, yes, you can actually factorize, right? You can factorize this expression. You can factorize this expression using 5, right? Or you can factorize it using xy, whichever one is best. Or you can also factorize using y, or you can factorize using x. Either way is going to give you the same answer. So 5 into 5 xy is going to just give you xy, right? And this is really a waste of time, so you don't need to go through all of this, right? And 5 times xy is going to also give you 5xy, which is also equal to, so if I use xy, xy into 5xy is going to give me 5, right? So it's the same thing. And if I also decide to use y, 5 into 5xy is going to be 5x, right? Either way, you're going to attain the same answer. Now, moving on to a more difficult question, and honestly, I can attest to that this question is not a walkover in terms of factorization, but it's just the same principle. It might look a bit scary, but it's the same principle you're going to apply in order to solve. So, firstly, identify the highest common factor, right? The highest common factor, we have 10x cubed y square minus 5x square y cube plus 15x4 y 5. So we realize that x and y is common to both terms, right? Not to both terms, but to all three terms. But because the exponents are different, so for example, we have x cube is not the same thing as x square and x4, x to the fourth, because x to the fourth is saying x times x times x times x, while x to the square, x square, sorry, is actually saying x times x, and x to the cube, or x cube, is actually saying x times x times x times x. So they are not the same, hence we can't add them or subtract them. But what we can do is we can factorize. Now, in identifying the highest common factor, we realize that 5 can go into all three terms that is present. And because x and y is common to both, to all three terms, then our highest common factor is going to be 5. We're going to, please, an important thing to note, that when you're factorizing an expression like this, you look for the lowest, the variables that have the lowest value, or the lowest exponent. So the lowest exponent that is present, we have x square, right? So x square, and the lowest variable, the lowest exponent of y is actually y square, right? So we can go ahead and factorize now. 5x square y square into 10x cube y square is going to give us So 5 into 10 goes 2 times, right? Let me write that 2 better. So 5 into 2, 5 into 10, sorry, goes 2 times. X square into x cube, leave x. Y square into y square cancel. So that's only going to leave 0. Not 0, but 1, which is not needed. Then 5 into negative 5 is going to give me negative 1, right? The 1 is not needed because we have the variables already. So x square into x square is going to be 1 as well. We don't need the 1 there as well. So y square into y cube is going to just leave us with y. And then moving on to the other term, which is 5x square y square into 5x for y to the fifth is going to give us 5 into 15 goes 3. X square into x to the 4 is going to be x square. And y square into y to the fifth going to leave us with y cube. So basically in this case, what we are doing is we are subtracting the powers. So like how I say, y square into y5, y to the fifth, or the fifth raised to the fifth exponent, I'm actually saying y to the fifth exponent minus y to the square, and hence I have y to the cube, right? And this is my final answer in terms of factorizing this expression. That should be it for this, for factorization, but let me go through one more question. So in the event where we have 9x square y plus 6x 4 y 7, right? How would we approach this question? It's basically the same principle. We have x and y common to both terms. Remember, we can't add them because the exponents are different of the variables. But we can identify the highest common factor in order to factorize. The highest common factor, so 9 and 6, the highest common factor of 9, the factors of 9 are 1, 3, and 9. The factor of 6 is 1, 2, 3, and 6. We realize that 3 is common to both. So the highest common factor is 3, right? X, but not just x. We identify the x that has the lowest exponent value, and that is x squared, as well as the y that has the lowest exponent value, and that is y, right? And then in factorizing 3x squared y into 9x squared y is going to just give us 3, right? Because x squared cancel x squared, y cancel y, right? So I'm just left with 3. 3x squared y into 6x to the 4th y to the 7th is going to just give us plus 3 into 6 goes 2 times. X squared into x4 goes x to the 2. Sorry, x to this x squared, sorry, was x squared. And then y into y to the 7 is just going to give me y to the 6. Right? And that is our final answer. Right? So it's pretty easy. Factorization is pretty easy. There's nothing complex about it. It's just for you to just follow the procedure based on the different method that you use, and you'll be okay. So thank you very much for watching this video. Thank you very much for your support. Please remember to like, share, and subscribe, and to share it to your family and friends. That this is the end of the video, so have a great time now. Thank you.